Okay, so I'm going to explain this handout. So what we're looking for is, how do I know that the sine law is going to lie to me? Or when it's not going to lie to me? So if I look, the first thing says to color all the triangles where x is obtuse. So if x is obtuse, I know that it could lie to me, but I know that that has to be an obtuse angle. The diagram is given. I've gone through and I've identified, so this one has to have an obtuse angle. This one has to have an obtuse angle, and so does this one based on the diagram. Then I want to know, how can I tell if x is not going to be obtuse? Well, I can tell by the diagram. There's already an obtuse angle in the diagram, so there can't be any more. So if I look, I colored those in yellow. So there's already an obtuse angle in these three diagrams, which means there can't be another one, because the sum of the angles in a triangle only add to 180. The other way is that we are looking for the acute angle in a triangle. The angle of the triangle is a right angle, or we're looking for the angle across from the shortest side. So if I look here on these orange ones, they've given me 65 and 34. I'm looking for angle x. It's across from the shorter side that I've been given. Same thing over here on this one. I've been given sides 10 and sides 12. I'm looking for the angle across from the shorter side. What should you look for when trying to decide if x is going to be an obtuse angle? Well, the angle we are looking for is across from the longer side. There isn't another obtuse angle in the triangle, and or the diagram shows an obtuse angle. So let's look at what our options are. So this is basically an investigation where you would use a ruler, and I would ask you to draw side BC at 5.4 centimeters. So you're going to take your ruler and you're going to measure out 5.4 centimeters. It would actually form a 90-degree angle with this dotted line, which means that only one triangle can be formed. It would be a right-angled triangle. The measure of angle C would be 90 degrees, and we would actually not use the sine law or the cosine law to solve for it. We would use either Pythagorean theorem or the sine, cos, or tan ratios. Option number 2, if I try and draw a triangle. In this case, I'm trying to draw it, and I've measured 4.3 to be side BC. Problem is wherever I put 4.3, it's never going to touch this dotted line, which means that I can't even make the triangle. So there actually is no triangle that can be formed, so no solution exists. My third option is that I have that BC measures 6 centimeters. Well, if I slide my ruler down, 6 centimeters is actually here, and 6 centimeters is actually here. So it means that actually I can form this triangle here, and I can form this triangle here. So it means, based on this side and this side, two triangles can be formed. This one would be the obtuse angle, and this one would be the acute angle. And I could find this angle first, and then I could find this one by doing 180 minus like we did in the previous lesson. So this is called the sine law ambiguous case. How do I know that the sine law may lie to me? Well, it might lie to me if no diagram is given, the given angle is not obtuse, and the side across from the unknown angle is the longest side. So it means we're looking for the biggest angle. It could be that the biggest angle is acute, but it could also mean that the biggest angle is obtuse. Summarizing the previous page, You could have no solution. That means you can't actually draw the triangle based on the measurements given. You could draw it, but it would only give you one triangle or one solution because the angle is now 90 degrees. Or you could have two solutions, one with an acute triangle and one with an obtuse triangle. So if I look, there's the longest side. They've already given me that angle. I'm looking for the angle across from the smaller side, so it would actually not be ambiguous because I already know the biggest angle is this one. This one, they've given me side 13. This is the angle across from it, but this is the bigger side. So it is ambiguous, which means I could have one of the three possibilities. If I look here, doesn't matter about the side length. The angle, one of the angles they gave me was already obtuse, which means there is no other obtuse angle in that triangle. So it's not ambiguous. If I look at the last one, I have sides 21 and 20. 21 is the bigger side. I'm looking for the angle across from it because they already gave me A and A angle A, which means this one will be ambiguous. So if I look, it says determine the possible measures of angle B. So if I look, I have side 68 and side 80. Side 80 is bigger, which makes this question ambiguous. So I drew a diagram. It's not a good diagram because I don't know if there's how many solutions there are. It may be that I do the work and I get error. If I get error, it means that the measurements they gave me don't actually work and I can't draw it. If I get 90 for angle B, it means that I should have drawn a right angle triangle. I wouldn't have known that until I've done the work. However, I'm going to solve for angle B, and I can clearly see that I got an acute angle, which means there are two possibilities to find or to draw the triangles. One, the acute one, and number two, I would have to find the other measurement of angle B, which means the other measurement would have been 180 minus the measurement I got for the first one. So the other triangle would have an obtuse angle of 115.68 degrees. If they wanted me to keep solving, this is what I've shown as well. If they want me to keep solving, well, if I solve this triangle, I can find the measurement of angle C. So I do 180 minus B minus the A they gave me. I would find angle C, and then I could continue on to find side C. And then I would have to do that all over again with the other measurement of angle B because now there are two triangles. So I can do 180 minus the angle A minus the other angle B, which means angle C in the second triangle would be 14.32, and then I could keep finding side C. They haven't actually asked me to do that, but I could do that if need be.